Hey everyone, and welcome to today's Explainer. I'll be your senior AI architect today, and we're going to be diving into an absolutely fundamental shift happening in artificial intelligence right now. You see, we're officially moving away from those simple, isolated large language models and stepping into the era of autonomous agentic AI. The bridge that's actually making this massively possible, it's called the Model Context Protocol, or MCP. Let's get right into it.
Here's our quick roadmap for the Explainer today. We'll start with the rise of agentic AI, move into tool taxonomy, break down the MCP architecture, tackle security risks, look at enterprise governance, and wrap up with the future outlook and our references. All right, Section 1, the rise of agentic AI. Let's talk about how we're breaking these models out of their isolated boxes.
To quote our source material directly, tools act as the agent's eyes and hands. Look, an advanced model is incredible. It can pass the bar exam, it can write stunning poetry, but on its own, it's basically trapped in a vacuum. It can only predict patterns based on its frozen training data. It can't check the weather right now, it can't update your live database, and it definitely can't send an email. So, tools are essentially the smartphone apps for your AI. They're the literal mechanisms that allow an agent to actually perceive and interact with the real dynamic world.
So, what is a tool exactly? Think of it as a formal contract between the LLM's reasoning engine and your internal systems. It's the definition that allows your AI to go out, retrieve fresh data, or execute specific external actions for a user. But here's the catch. For this to work seamlessly, the foundation model has to know exactly what the tool does, what parameters it needs, and precisely how to use it so it doesn't just start hallucinating inputs.
That brings us to Section 2, Tool Taxonomy and Best Practices.
In the enterprise world, we generally drop tools into three distinct buckets. First up, custom function tools. These are the external functions you'd script yourself, like a custom Python API to query a warehouse database. Second, we have built-in tools. These are implicitly provided behind the scenes by platforms natively. Think Google Search or direct code execution inside environments like Gemini. And finally, agent tools. This is pretty cool. It's where your main routing agent actually offloads specialized tasks to secondary expert subagents, all while keeping a tight grip on the master conversation state.
Now, when your engineering teams are building these out, there are some absolutely crucial best practices. You want to expose highly granular actions, not just wrap some massive, messy enterprise API into a single endpoint. And look, as developers, we all kind of hate writing documentation, right? Well, in agentic AI, your documentation is literally the programming interface. The tool's name, its description, the parameter schemas, all of that gets fed directly into the model's context window. So you have to describe exactly what the task achieves. And please, design for concise outputs. If your tool dumps a massive unfiltered JSON payload, it will completely blow up the model's context window and wreck its reasoning.
All right, moving to Section 3. Let's look under the hood at the MCP architecture and its core primitives.
Historically, integrating these models with external tools meant building custom, one-off connectors. If you've got n number of models and m number of tools, you very quickly end up with an exponential n times m integration nightmare. Absolute integration spaghetti. Every time someone spun up a new tool, it meant writing totally bespoke code for every single AI app touching it.
But the Model Context Protocol beautifully standardizes all of that chaos. If you're looking for a step-by-step guide to building a custom MCP server, here is the blueprint. Step 1. You separate your AI application, which we call the host, entirely from your tools. Step 2. You embed an MCP client directly inside that host. And Step 3. You build a dedicated MCP server to securely hold and expose those external tools. This brilliant client-server setup completely decouples the agent's complex reasoning loops from the actual nuts and bolts of the tool implementation. Digging a little deeper into the plumbing here, the communication layer runs on a super lightweight JSON RPC 2.0 format. It uses 4 standard message types: requests that need an answer, results holding the output, errors for when things go wrong, and one-way notifications for state updates. To move these messages around, MCP gives you options. You can use Studio or standard I/O for incredibly fast local execution, or streamable HTTP if you're bridging remote distributed enterprise networks.
Now, beyond just running functions, MCP uses a few other vital primitives. Servers can offer resources, which let the host pull read-only contextual data, like corporate PDFs or system logs, straight into the model's memory. They also use prompts, which are basically reusable instruction templates. But as an architect, hear me clearly on this. You have to be incredibly careful here. Injecting external prompts or resources from an untrusted server is super risky because they can easily carry malicious instructions meant to hijack your entire application.
And that perfectly tees up Section 4, Advanced MCP Security Risks. You see, standardization gives us incredible velocity, but the open nature of MCP cracks open a vast new threat landscape. Because tools load dynamically at runtime, if you expose your internal enterprise APIs through MCP without robust native authentication, you are asking for trouble. Without strict zero-trust controls, you're practically handing over unauthorized access to your sensitive, proprietary information. And that leads straight to catastrophic data exfiltration.
Let's look at two really nasty advanced risks. First, dynamic capability injection. Imagine a harmless, read-only poetry writing agent. Suddenly, a compromised server silently injects a high-risk purchasing tool into the session. Now, your previously safe agent can spontaneously initiate financial transactions without you even knowing. Wild, right? Then there's tool shadowing. This is where a malicious tool cleverly spoofs its description to look exactly like a real one. It completely tricks an AI coding assistant into, say, saving a secure database password right into a hacker's vault instead of your safe corporate secrets manager.
All of this culminates in what we call the confused deputy problem. Here's how it plays out step by step. An attacker wants to steal a proprietary algorithm from your lockdown codebase. They don't have direct access, but your internal MCP server does. So they feed a sneaky prompt injection to your public-facing AI assistant, telling it to quietly search for the secret algorithm and copy it somewhere else. The AI, the unwitting confused deputy, passes this seemingly normal request to the highly privileged MCP server. The server trusts the AI, executes the command, and boom, the attacker just bypassed your entire security perimeter.
So Section 5, Securing Enterprise Agentic Systems. How do we actually stop this?
To mitigate these massive exploits, we absolutely cannot rely on the base protocol by itself. Platforms like Google's Gemini Enterprise Agent platform on Vertex AI are stepping up as these impenetrable API gateways. They give us centralized agent registries to enforce strict tool allow lists, meaning those dynamic capability injections are literally impossible. They assign cryptographic agent identities, so every single action has an immutable audit trail. And they use tools like Model Armor to actively inspect payloads, sanitizing inputs and blocking prompt injections before they even touch the model. Oh, and you also have to implement taint tracking to make sure sensitive data fetched by an internal tool isn't accidentally blasted out to the public web by another tool.
Finally, Section 6, the future outlook and our references. Looking ahead, we are definitely hitting a wall with context window bloat. If you load hundreds of tool schemas at once, it severely degrades the AI's reasoning. So the future is going to shift toward dynamic, RAG-style tool retrieval. Instead of loading everything at startup, the agent will dynamically search a semantic library and retrieve only the specific tools it needs for that exact second. And, considering the severe security stuff we just talked about, expect to see enterprise adoption move aggressively away from the pure, decentralized open protocols and heavily toward tightly guarded, centralized API gateways.
I want to give a huge professional shout out to the amazing authors of our source material today: Mike Steyer, Kanchana Patlola, Madhuranjan Mohan, Santiago Diaz, and Anant Nawagaria. Their paper, updated in May 2026, laid the absolute groundwork for the architectural deep dive we took today.
Which leaves us with this final thought. As we give our agents the real-world power of eyes and hands, as they gain true autonomy, who is truly steering the wheel in your enterprise? Thanks for hanging out with me for this explainer. Keep building and keep it secure. Catch you next time.